Now let's move from counting to probability. I have here written here that there are 3 different types of probability calculations, but really it's 2. The third one that your book says is just sort of intuition, using your intuition, like, I think the probability that this team's going to win is about 90% or whatever. That's not really a way to calculate, so there's only 2 ways to calculate probability. Let's start with some notation that's commonly used when we're figuring probability. When you see this P within something in parentheses, P means the probability of, so this means the probability of event E. So what's the probability of event E happening, okay? So let's look at the first probability, probably the probability you're most familiar with. It's called classic or theoretical probability. And that's used when each outcome is equally likely to occur. Like if you toss a coin, it's equally likely to get heads or tails. If you roll a dice, you're equally likely to get a 1, 2, 3, 4, 5, or 6. So this is used for equally likely events. So what you do to calculate the probability, so the probability of event E is just the number of outcomes for event E over the total number of outcomes in the sample space. All right, so let's look at an example. What is the probability of rolling 2 dice and getting a sum of 5? So we're going to write this as, this is my event E. So this is E. Rolling 2 dice and getting a sum of 5. So we're going to say the probability of E, which is the probability of the sum of 5, equals the number of ways to roll 5 over the number of 2 dice rolls. Okay, so I need to know how many different rolls different possible combinations of numbers can I get with 2 dice for my sample space. So I need to know the sample space for rolling 2 dice, and then I need to know the number of ways to roll a 5. Well, we can use the fundamental counting principle to find the sample space for rolling 2 dice, because I'm going to write this down here. Sample space for 2 dice. Well, it would be 6 different numbers for the first dice times 6 different numbers for the second dice. So there's 36 different ways to roll 2 dice. And you can see this in the charts. There's 6 across and 6 down. So I actually use 2 different colors here so it'd be easier to see. So I could get 2 1s. I could get a 1 and a 2. I could also get a 2 and a 1, because a 1 on the white dice and a 2 on the blue dice is a different outcome than a 2 on the white dice and a 1 on the blue dice. So that's 2 different outcomes. So I could get a 1 and a 1, a 1 and a 2, 1 and a 3, 1 4, 1 5, 1 6, or 2 1, 2 2, 2 3, 2 4, 2 5, 2 6, etc. So for each of the first numbers, I could get 6 different second numbers. So we're multiplying 6 times 6 to get 36. So the denominator of my probability would be 36. There's 36 different ways to roll 2 dice. Now the numerator is the number of ways to roll 5. So I'm going to go through and find all the different ways to get a 5. Well, I could get a 1 and a 4. On the next line, I could get a 2 and a 3. Or if I rolled a 3 first, I could get a 3 and a 2. Or I could roll a 4 and a 1. So there are 4 different ways to get a 5, or 1/9. So the probability of rolling a 5 with 2 dice is 1 out of 9. That's my probability. Now there's other ways to count the total number of outcomes and the total number of outcomes in the sample space besides using the fundamental counting principle or listing out, making it some sort of a diagram. Another way is to use what's called empirical or statistical probability. So empirical or statistical probability is based on observations obtained from probability experiments. In other words, just using data. And the probability is the relative frequency of event A, or the proportion of times that it happens, the percentage of times that something happens. So remember, relative frequency is a percentage, and a percentage is another way to write a probability. So let's say I've got a table of responses to my student survey, and for the question, who brings you to school, your parent, another student, or myself, I had a total number of 45 responses, and these are how many responded in each of the categories. So if I want to find what's the probability that the parent drove you to school, well, I'm going to look at the number of different responses I got for parents driving, which was 19, divided by the total number of responses. So 19 divided by 45, which turns out to be 0.422 or 42.2%. All three of those ways are equally valid ways to express a probability. I can say it's 19 out of 45, or it's 0.422, or it's 42.2%. All of those can be used to express probability. Notice the 42.2% is also the relative frequency, or we could also call it 0.422. And if I did 16 over 45, I could get the relative frequency, or the probability that someone chose other student as their response. That would be a 34.6 or 35.6% probability. Or if I did 10 over 45, then I could get the other 22.2%. So there would be a 22.2% probability that someone chose myself. So when I say probability, I'm saying if I took these 45 responses and put the names of those students in a bag or something and randomly selected one, the chance or the probability that I selected someone who chose my parent drives me would be 42.2%. Altogether, of course, this would add up to 100%. Another way to get the same type of information would be from a graph. So I've got a histogram of how many hours do you work per week. And I have 0 to 5 is my first bar, 5 to 10 is my second bar, 10 to 15, 15 to 20. Then nobody worked between 25 and 30 hours, and then I have a small group that worked from 30 to 35 hours. So I could ask some probability questions about this. I could say, what's the probability that the student worked 0 to 5, or I should say works 0 to 5 hours per week? Well, I'm going to read off, I need to look at the height of this bar. Well, this height says 0.5. Does that mean half of a student worked 5 hours per week? No. This is clearly not labeled in numbers of students. This is labeled as relative frequency. This is relative frequency. It's telling me what percent, basically, but in decimal form, the decimal form. So 0.5 or 1/2 or 50% of the students worked 0 to 5 hours per week. So I would say that would be my probability, 0.5. Now, what about the probability that a student works more than 10 hours per week? So I'm going to look at two different bars. I'm going to look at this bar and at this bar. Or sorry, more than 15 is what I meant to say. More than 15. Just misread my graph. I'm going to look at those two bars. And if we look over to here, we can see that looks like it's about 0.05 or about 5%, because 0.1 would be 10%. So this would be 0.05 plus another 0.05 or 0.1 or 10%. We could also say this is or 50%. So those are two different ways. So notice my total in this case, I didn't actually, so basically I'm thinking out of 1 or out of 1.5, if we thought of this as one whole, the area is one whole thing here, or 100%, we could say half of them, 50% of them, work from 0 to 5 hours. So in this case, I'm not really using a fraction at all to divide. I already have the probability listed for me as the height of the bar. So that's another way to read probability from some information you're given. Now let's just summarize the different ways that we could figure out this number of outcomes of event E over the total number of outcomes in the sample space. How do we get these two numbers? Okay. So how do we get these numbers? Okay, so one possibility would be use the fundamental counting principle. That's how I did the total number of outcomes in the first example here. Number 2 would be a tree diagram, or some sort of chart showing possibilities like this one. Tree diagram or chart of possibilities. I can't fit the of possibilities in here, but I've kind of diagrammed out all my possibilities here. So that would be another way to get the total number in the sample space. So fundamental counting principle, tree diagram. Another way would be a frequency table. I could use the frequency table to get my total number of people and how many are in each category. Or the relative frequency, I could actually get my category and the probability just from the relative frequency. And I could have a graph. The graph could tell me how many are in each category, or it could tell me the relative frequency or the probability for each category. So I could sometimes just read that right off the graph. So all those are ways that we can figure out what those frequencies and total frequencies are.